time. Okay, so last time we talked about I can walk. I mean, we discussed chapter 10, section number 3, and we talked about the percent composition. I assume that by now you know that we have two methods or two ways, or we have two set of data that we can use in order to calculate the percent composition of any compound. Either if we have the mass of that compound and the masses of the elements. So in that case, we can use, let me just take you over there. Well, I should move it from here. Maybe it's better. Okay, I think, yeah, that is the one, the first one. No, this is the using the chemical formula. I want to see the first one. This one, okay? So this is one of the ways. If you were provided the mass of the element and the mass of the compound, then you just do the percent composition of each element. Or sometimes you were provided with the formula, the chemical formula. Then from the molar masses of the elements and the molar mass of the whole compound, you can calculate the percent composition of each element in there. Now, we talked also about using the we talked about using the percent composition as a conversion factor, because when you say 30% or 40%, that means 40 over 100. So that's a conversion factor that you can use for any other case. If I give you the percent composition, then you can use that in order to determine how much an element is found in a compound. Yani, like the case of this example. Yes. I don't know where's the example, but yeah, this is the one here. We say calculate the mass of the carbon that is in and hydrogen in 82 grams of the C3H8. Now, from the previous example, we know that the percent composition of that is 82 and 18%. Either you can use it from a previous example, or it will be provided to you. Like I say, for example, in this case, the question will be calculate the mass of carbon and the mass of hydrogen, 80 grams of this, if the percent composition is 82 and 18%. So in that case, for the carbon, you need to multiply 82 grams times 82 over 100. And the 82, the second one, again, as I said last time, I don't know why they choose 82 grams to confuse you, but assume that it is any other number. So you multiply it by 82 over 100 to get the carbon. You multiply the same by 18 over 100 to get the hydrogen. That is number 3 of the things that we have learned last time. The second thing was, or the fourth thing, as a matter of fact, is the empirical formula. First of all, we have defined the empirical formula, and this is very important for you to understand that it is the lowest whole number ratio between the elements when you write a formula. Okay? The empirical formula is not, I don't want to say it's not real, because that's not true, but also it is not the one that we use. We use a molecular formula. And the difference between the molecular and the empirical formula, in terms of mathematically, we're going to see today how they are related. But in terms of the definition, they are different by the fact that empirical formula is the lowest whole number ratio, while the molecular formula is the actual ratio. يعني, let me tell you what does that mean. For example, if you consider ethine, which we talked about last time, that is, why this is not writing. مشكلة. نرجع نعيد. Every time I touch it. بدينا في المشاكل. طيب خلينا نشوف إن just I want to how can I take out this? Yeah, I want to go here. So I want to see, is there anything here that we can do? When? هون ايه الفول سكرين. طيب ايش هذا؟ ضغطنا على الرونج. طيب هنا بالماوس قصدك؟ هنشوف. عمي وين تحت؟ انتوا تشوفوا شيء انا مش شايفه؟ ها وين تحت؟ لا من هنا I cannot. This I will use annotate and that is different. That's different from writing. I need something where the pin was shown over here. I don't know what happened. لازم يطلع، انا عارف انه لازم يطلع، بس انت تقولي انه هناك وانا مش شايفه. فكرتك شايف شيء يعني. Anyways, هاي اللي بكرهه انه you need to solve a problem while you are doing the lecture. Okay. شوف هذا. Just hold on a second, okay? ها شو هذا؟ اوكي هنشوف اذا هاي بتغير شوي في الموضوع. نعم نفس الشيء. Okay, serial number, power system, display language, display. We have in the display system. وينها؟ This one? Library, mobile, saving, notification, screen share, system, power, audio, date, language. إذا بتحب نغير language. Smart cloud. طيب يعني كيف بدنا نرجع محل ما كنا؟ هذا السؤال. I think from here. Yeah. Connecting. خلاص ما فيش مشكلة. We can do it without writing. بكتب لكم إياه هيك في الهواء. Okay, so as I said, the difference between empirical and molecular formula is like actual and lowest whole number ratio. كمان مرة C2H2 is a compound, isn't it? And that is, no, C2H2 is the molecular formula for ethine or acetylene. All right. Now, what is the empirical formula for that? Is CH. So what is the difference between CH and C2H2? That's an actual one, and the other one is the lowest whole number ratio. Now we're going to see how they are related in terms of numbers. You see, that's the example I was referring to. Between this one and the CH, this is empirical and that is actual. We learn how to calculate the empirical formula from the percent composition. And that is by, first of all, you have, when you were given the percent composition, you have to assume that if you have a 100-gram sample, then the percentages will be grams too, right? When you say, for example, the percent composition is 40 and 60%, if you have 100 grams, then you have 40 grams of this and 60 grams of the other one, right? So what you do is you change that percent into gram. That's step number one. Step number two, you change all the grams into moles, and you know how to convert that. I don't have to repeat it again, using the molar masses of the element. Once you get the moles, that is your mole ratio. But that will be a fraction. Remember that we said that the empirical form is the lowest whole number ratio. So that's why it has to be divided by the lowest. Original multipliers. Okay, so it has to be divided by the lowest number, and that will give us, one of them is going to be 1, and the other one will be a certain number. If both numbers are whole numbers, that's it. If not, then we have to multiply by a factor, and that's what we have seen in the case of this into. See, this is how you convert into moles, and then it is like that. See, that's what I was referring to. If it is like this, these are fractions. So to get rid of it, you divide by the lowest, and that will give you 1 for this one, and is going to be 2.5 for the other one. That's where we multiply by a factor in order to make this a whole number. So it will be N2O5. Okay, that will be the case. Unfortunately, there are not too many examples in here, but the homework, by the way, is been put in the, I think it will open at 11 today, and will remain open for you till Saturday, the last minute of the day. So you have plenty of time عشان ما حد يقول I forget I have internet مش عارف شو. You have 5 days. ما في يعني whoever missed that, please don't send an email والbegging هذا. لانه اكثر من 5 ايام ما في other يعني. anyways في هاي الهومورك في at least 3 or 4 more examples on how to calculate the empirical formula from the percent composition. Okay, since we're speaking of the homework, I remember now there's one of you which is, what's his name, Hashim Al-Attas. Are you there? Yeah, Hashim. طيب حين ندور اسمك ونلاقيكم قاعد في الزوم. Anyways, لهاشم وكمان 2 students who missed the, يعني you can tell them if you know any of them, who missed the final. The exam will be, the makeup exam will be tomorrow at 12. Dr. Abdurrahman is sending them emails, but they should know where the location is. طيب بعدين اليوم نطلع مباشر. Okay, the molecular formula again and the empirical formula. As I said, this is actual, the other one is the lowest whole number ratio. But I want you to look at this table to see in terms of the numbers, how they are related. This is ethine, which is C2H2. That's a molecular. And the molar mass of that is 26. Now, if you look at the empirical form of that, which is the CH, it is 13. The relationship between 13 and 26 is double, or there's a factor, as a matter of fact. If you want to know more, take the C6H6, which is benzene. The molar mass is 78. That's also a multiple of 13. So the molar mass of the molecular formula is a multiple of the molar mass of the empirical formula. That's what I'm trying to tell you. So if you have the empirical formula, let's say you did the percent composition and you know the empirical formula, you want to know what is the molecular formula. What you need the molar mass of the molecular formula. If you have that one, like for example, let's say I have a gas, which is, I don't know if it is ethine or not, but I gave you the percent composition, you did your calculation, you reach up to the point that the empirical formula is CH. That's number one. You calculate what we call empirical formula mass, EFM, they call it, and that is 13. Then if you know that, if I'm telling you that the molar mass is 26, you divide 26 by 13, that is 2. So you need to multiply this by 2. If you multiply this by 2, then you're going to get into the C2H2, right? Is that clear? Everyone? Okay, so again, I'm saying that if you have the empirical formula, what other information you need to get the molecular formula? You need the molar mass of the compound. If you have the molar mass, then you divide the molar mass of the compound, which you don't know the molecular formula yet. You divide it by EFM, which is the, or empirical formula mass, yes, EFM. All right. If you divide it by that, you will get a number. That number is the multiplier, which is you need to multiply the empirical formula by in order to get into that. Okay. If the empirical formula and the molecular formula are the same, and we have cases like that, we already stated that empirical formula might be the same as the empirical formula or some multiplier. If it is the same, then that multiplier will become 1 in that case, because the molar masses will be the same. Let me just give you, so either it is the same as the experimentally determined empirical formula, or it is a simple whole number multiple of its empirical formula. All right. So for that reason, all what you need, once you have determined the empirical formula, then all what you need is what? you need the compound's molar mass. If you have that one, then you can divide the molar masses of the empirical formula by whatever you have, and that will give you the multiplier. That is the EFM, which is the empirical formula mass. Divide them and you'll get that. Here's an example so you know what I'm talking about. Calculate the molecular formula for a compound whose what is it? Molar mass is 60. So he's provided you with the molar mass of the compound, not the empirical formula. And has an empirical formula. يعني هذا مختصر عليك خطوة, which is instead of giving you the percent composition, if you want to make the question a little bit more harder, to give you this one, we'll say, and the percent compositions are 20%, 60%, and 20%, for example, for different elements. So what you need to do, you have to go through the calculations, find the empirical formula, find the mass for that one, divide this by that one, that will give you the multiplier, then you multiply it by that number. So in this case, what is the molar mass of the empirical formula? That is 12 for carbon. Here it is, 12 for carbon and 4 for hydrogen, 14 for nitrogen. That's a total of 30. Okay, so what is this 30 grams per mole? This is the EFM that I was referring to, which is empirical formula mass. Then all what you need to divide this by that, the number is 2. So the molecular formula will be 2 times the empirical formula that you have. So you multiply C4HN with 2, and that will give you C2H8N2. Okay? This is, I think, the last part which was left for us to do in this. The question again, what information in addition to the empirical formula I don't know when this comment was, but that's fine. In addition to the empirical, what is necessary to determine the molecular formula of a compound? The molar mass, not the mass, yeah, Ghaida, but it is the molar mass. Yes, the molar mass of the molecule of molecular. Well, the molar mass of the compound. That is much easier. Okay. So that's it for chapter 10 for the section 3, and now we're ready to move to chapter 11, if you don't have any questions. Nope. Okay. Let's open the chapter 11 lecture. This is the other one. Okay, then we go to the Zoom and do new share. This is okay. Chapter 11 is about matter and change. We're going to talk about chemical reactions now. With chemical reactions, first of all, this one, section 1 of today, is very, very basic. I can tell you. Some of you might say, why are we going through this? Simply because some of you forgot this information. So we want to remind you of what you know already about writing a chemical formula. That's what we will be doing in this section. Then after that, after you learn how to, if I give you the names of the compounds that were involved in the reactants and become a product, then you should be able to write a chemical equation. Then we move to the second section where we talk about the types of chemical reactions. There are 5 types of chemical reaction that we need to discuss, including the composition, combination, the whatever, يعني, number 3. وفي ال replacement, في single replacement or double replacement. These are the 5 types of reaction. Okay, once we do that, there's a special type of reaction, which is reactions in aqueous solution. When we have the reactions in water, they have a special treatment, which depends on the solubility of the compounds that we are mixing together and the solubility of the product. We will teach you, through a table, that which one will produce still a soluble material and which will produce a solid material. Again, you have 2 solutions that let's say we have 2 reactants, okay? They react with each other, but each one of them in solution, they are soluble. Okay, we have solution of A and solution of B. We mix them together, then we notice some solids start coming in. That is because the product that is produced from that reaction is not soluble. How would you know? We'll give you a table, and you have, so to speak, you have to memorize that. And to know which one will give you a precipitate and which one will not. And of course, after that, there will be some more details, more than that. All of that will be discussed in section 3. So let's start with section 1, which is we need to learn, again, as I told you, I want to warn you, I don't want to see some people saying, oh, why we're doing this? This is very, trivial, but I can tell you that more than 50% of you, they don't know this information as we speak. I describe how to write what we call a skeleton equation. شو معناه skeleton equation, we'll see. And describe the steps for balancing chemical equation. And balancing chemical equation should be straightforward, but we will see how to do that. طيب هذا موضوع يعني just a question and a picture as usual to introduce you to what we're talking about. أكيد سمعتوا في الفيول cell car. يعني the efforts of the scientists to replace using the petroleum is ongoing for a long time and still ongoing for now, because they know that this fossil fuel kind of materials needed to generate energy is going to finish at one time, so they need a replacement, and they're looking for different types of those. This is one of the alternatives, which is to use a fuel cell. The only problem with that is it is about the reaction between hydrogen and oxygen. When they react in a cell, they will produce electricity, and that electricity can be used to run a car or run any other machine. So they can produce electrical energy from that. But the question is where you get the hydrogen from. Oxygen is available everywhere, but the hydrogen, making the hydrogen is very difficult. So that's why it's not feasible. But feasible meaning economically feasible. But scientifically, yes, it is very good. So anyways, the question is how the chemical reaction is going to change the way you drive is by using a chemical reaction. Here what's going on is a chemical reaction between hydrogen and oxygen to produce water. Anyways, it's not important more than introducing that. How do we write a skeleton equation? Before we do that, well, you are aware of this information here, that reactions are going on everywhere, inside you, outside you. All the living systems, they are undergoing continuous chemical reaction. You don't know how many chemical reactions are going at this time in your body, especially if you had your breakfast. So things that you put in there, now it is reacting. And outside the plants and any other living system, they have continuous reaction. So that's why it is important. All chemical reactions, we are changing substances from reactants into products. That's why I told you that it is very basic. You know that reactants will go to the products when we have something like that. If you mix all these together, what you're going to get? A muffin, if you're good in cooking. If you're not, then you're not going to get a muffin. You're going to get something which is not eatable. But anyways, this is also a chemical reaction, because basically you put ingredients which they have chemical compounds, the eggs, the flour, the sugar, and whatever, and you heat it up. So when you heat it in the oven, that's what is basically a chemical reaction that will result in your making your muffins. If you want to write that chemical reaction, you would write eggs plus this plus that. That's what we call word. Well, before that, this is again something that you know, that we have reactants going to the product. Usually the way we read it, we say material X reacted with Y to produce so and so, or we say yields or gives. That arrow means that it gives, yields, or produces, whatever. Okay. This is a rusting reaction for this car, for example. It's been there. The reaction that is producing this brown color is the rusting of iron with oxygen. So what we write here is what we call a word equation. Word equation is wasting a lot of time, because you will be writing iron plus oxygen to produce iron 3 oxide. Instead of doing that, you can change that into simples. That's why we have simples for the elements. But anyways, this is a a word equation. Word equations, again, we have the reactants in the left and the products in the right, and we have an arrow in between. This is another good example. There are two reactions actually going on here. The first one is the burning of the gas. That is a reaction between the methane gas and the oxygen in order to produce carbon dioxide and water. But there's a reaction going inside because you're cooking something. And that is another reaction. But the energy produced from the first reaction is used in the second reaction to make the whatever you are cooking. So chemical equation, what is the difference between a word equation and a chemical equation? Word equation, that we put the names of the compound. When we say chemical equation, we use the symbols. So instead of saying iron plus oxygen to produce iron 3 oxide, we're going to write FeO2. But look at this one. That does not indicate the actual amount that is using. And that's what we call skeleton equation, which doesn't have information about the quantities. Whenever the equation does not have the information about the quantities, or in other words, whenever it is not balanced, then in that case, we call that skeleton equation. But skeleton equation has more information than what you see. In addition to this, you can write also to write a skeleton equation, you need to write this. Yeah, you have to specify the states of the matter. Iron, is it a solid or a gas or a liquid? You have to specify that by using S, L, and AQ for aqueous, which means that it is soluble in water. That's what it is. And G for gas, L for that. So adding these states of the matter, still we are in the skeleton equation, which is having only the simples without putting the quantities together. Sometimes we put something like this, that we call it a catalyst. Now, it's not a big deal at this time for you to understand what a catalyst means. I think you will know more in the biochemistry, most likely, when you talk about enzymes being used as a catalyst, which is to enhance a reaction. The catalysts are there in order to make the reaction, but they're not involved. Here, as you can see, these are the reactant, these are the product. What happened to this MN? It is just helping the reaction happening, but it does not interfere in there. That is what a catalyst is about. Anyway, these are other symbols that you all know, which is we use the plus sign when we have more than one reactant or more than one product. We use the arrow whenever the reaction is going into completion, that all the reactant will be transformed into product. But whenever there's a equilibrium that is going back and forth like that, we use a double arrow to show that both the reactants and the product will exist at the same time. This is the state of matter. The aqueous means this is the triangle means also heat, the same thing as the word heat. That's for the catalyst, or PT for platinum, which is usually sometimes they do the reactions on the surface of a platinum plate in order to get some electrons, and that will help the reaction to go on. Writing a skeleton equation. In order to write a skeleton equation, what you need then, after all what you have learned so far, you need to know the formulas of the compound. And when I ask you to write a skeleton equation for a reaction, I will say iron reacts with oxygen to produce, or sodium chloride reacts with potassium hydride and whatever. So this is, again, will depend on your information from chemistry 1, how to write formulas for chemical compounds. That's something we have learned a long time back, right? Yani when I wrote now iron 3 oxide with the 3 numerals, that is something that you learn. Why we need to specify the oxidation state? Because there are 2 oxidation states of iron. Indicate the state of the, well, first of all, write the correct formula. This is number 1. Write the state of the matter accurately according to the information provided to you. Separate them by an arrow, or separate the product and reactant by plus sign. I use the plus sign when you have more than one reactant. These are the 4 steps for writing any chemical reaction as a skeleton equation. Is there any comments here? هذا لسه بعدين في الcombustion. Okay. طيب. That was the introduction. Here's an example. Well, كيف أجي example? Let me just go back. So read the question. على طول. Here's the question. It's here. If the question will be like this, hydrochloric acid. When you say hydrochloric acid, that means what? And how they will be written? HCl, and it has to, how do I know that it is aqueous? Because we said hydrochloric acid. If it is not, if it is a solid material or something, it will be written in a different way. Anyway, react with the solid sodium hydrogen carbonate. What is sodium hydrogen carbonate? Sodium hydrogen carbonate, which is CO3. So NaHCO3, that's what it is. Then the products formed in is an aqueous sodium chloride. You know what sodium chloride is. Water, which you know. Carbon dioxide, that you know. Okay. So what you need to do is to write these are the names. These are the reactants. These are the products in terms of names. Then you write them in formulas. NaHCO3, then you put them in this way. This is what we call a skeleton equation that has all the formulas for the reactants and for those products. They are separated by arrows and plus sign. The state of the matter is there. Okay, so this is a skeleton equation. That does not indicate the quantities, how much of this reacts with how much of that in terms of moles. That's what is needed to, so balancing a chemical equation, we need to follow steps, and that is very simple. You need to make sure that the number of atoms in both sides are the same. Why? Because material never created nor can be destroyed. You started with 2 atoms of hydrogen, nothing is going to happen to them. They will breaking bonds, making new bonds, but they will be there. So when we have a chemical reaction, simply we are breaking things in. Let's take this very funny example, which is if you were working in a place where they make bicycles, and they give you the total number. They say we need to produce this much of, well, that will be in chapter later on when we say how much of that. But for now, if you want to make one bicycle, you need these parts, which are the frame, the wheel, the handbar, and the pedal. So these are the reactants, those are the product. Of course, you know that the wheels has to be 2. It's a bicycle. So on a tricycle, we need 3. Okay, so it does not indicate the quantities. So we put them like that, frame, 1W, 1 this, 1 that, and this is the formula of the whole compound. This is a skeleton equation still, because it does not indicate the actual amount. But if you look at the W, which are the wheels, we need 2 wheels, so this has to be multiplied by 2. The pedals has to be multiplied by 2. That is the way we change from a skeleton equation into a balanced chemical equation. All right, this is a theoretical example. I'm just going to skip that one. The coefficients, which are the ones that we put in front of those, has to be whole number. In some later on, you're going to see that it is not always the case, but for now, it is a whole number. In some equations, later on, you will see that we have half a mole of oxygen, but that is something has a special case. Don't worry about it now. All these numbers, coefficients that are written in front of the compounds, they are whole numbers. Okay. So balancing a chemical equation on each side of the equation. I'm just going to go a little bit fast on that because that's something you know. Again, chemical reaction is about bond breaking and bond making. بس في عندك 2 compounds, they will produce completely different compounds. How that happened? Because we broke some bonds and we make some new ones in order to produce. So بصير في rearrangement of the atoms. That's what happened. But the number of atoms has to remain the same. In any chemical reaction, the mass is conserved and the number of atoms is conserved. Number of moles is not. And you saw, or you will see many reactions where we started with 3 moles of this, with 2 moles of that, to produce only 1 mole of whatever the product is. The number of moles does not have to be, because it is just how much material we have. And the grams, in terms of saying, for example, we started with 2 reactants, which is 20 grams, that we have to produce something which is 20 grams. In terms of the atoms, yes, that is true. Okay, so To write a Benz chemical equation, first you write the skeleton equation. That's for sure. You were given the names of the compound, you write it, you put the state of matter, blah, blah, blah. And then you use the coefficient in order to balance the equation by counting the number of atoms in both sides, making sure that they are the same. And if you check one of them and then you change another one, then you have to recheck the first one because it could be involved in that first one. مثلا carbon with oxygen to produce carbon dioxide. Is this a balanced equation as it is? Yes, it is. Why not? ليش لا؟ عشان هاي مضيعتك الشيب هنا في O2. هاي carbon, هاي O2, هاي CO2. Number of oxygens is the same, number of carbons is the same. So this is a balanced equation. ما في داعي إن you don't need to change any of the coefficients. This is another one, which is H2 with O2 to produce water. Now look at the two hydrogens, two oxygen, one oxygen. So we have to do something about that. We have to increase the oxygen this side into 2. So we multiply this by 2. That's what I was referring to. You have to go back to the hydrogen again because it's involved in there. You multiply this by 2, and that will make it looks like that. 2H2, 2 moles of hydrogen with 1 mole of oxygen to produce 2 moles of that. Here's the moles that I was referring. Look at the moles here. How many moles we have? 3. 2 and 1, that's 3, right? And how many moles we produce? 2. And that's okay. There's the number of moles is not conserved. But if you look at the masses, yes, they have to be conserved. If you count the mass here, we have 18, which is the molar mass of water times 2, that is 36, right? 20 oxygen times that is 32, و4 36. The number of atoms and the grams, the molar masses, has to be conserved. ليش؟ لأنه الماتيريال or matter never can be created nor can be destroyed by humans. طبعا ربنا قادر على أن يخلق material بس احنا we cannot. لا بنقدر نخلق ولا بنقدر to destroy. يعني ما بتقدر تأخذ hydrogen atom and you remove it from this whole universe. You cannot. So again, this is the way we balance chemical equation. خلينا نشوف a little bit more. Yeah. Yes. That's the way we read the equation. طبعا هذا الكلام we'll confirm it later on في chapter 12. When we put the coefficient, yes, it says that either moles or molecules, if you wish, that's fine. As long as you know that this much of that is needed. The relative between the coefficients are confirming the relative amounts of the reactants and product with each other. It could be molecules, it could be moles, but usually we use the moles. One of the things that we learn in chapter 12 is how to interpret a chemical equation. That is meaning how to read it. When you read it the way I read it, which is 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. That's what we do. طيب, this is a good question. The reaction between oxygen and hydrogen in a fuel cell produces energy to the power car. What are the products of the reaction in a fuel cell that make the fuel cell a zero emission car? شو يعني zero emission car? Waste. One of the problems that we face with using the petroleum is the waste that it produces a lot of carbon dioxide. وهذا اللي يخرب الأوزون. You know that, right? A lot of carbon dioxide, not only from the cars, but from the plants and factories and around the world. You know how much carbon dioxide they produce per day or per minute? A lot of carbon dioxide, which is poisoning the atmosphere. So what they're trying to do with moving into the fuel cell is to reduce the emission. طيب, well, what is the product here? Which is zero emission. يعني ما في أي product that is harming the environment. What product that is produced from hydrogen with oxygen? Water. كمان ما احنا الحين جبنا الايكويشن نسيته في ساعه على طول. مش الحين عملنا hydrogen with oxygen to produce water. طيب الووتر هذا is it يعني something that will harm the environment? ما هو it's part of the environment. So that's why it is zero emission. Water is not a pollutant. It is not polluting anything because and that is the problem. طيب. These are some rules of how to balance chemical equation. أنا عشان أريحكم I highlighted the one which are important. The rest are normal things that you know. يعني مثلا determine the correct formulas for the reactants. أكيد تعرف إنك how to do that. صح؟ Of course you have to follow these. Put arrow, sign, or plus وإلى آخره. These are not. This is what's important. The one in red, because these are the one you may have forget with time. First of all, when you are counting the atoms, if you have something like polyatomic ion, شو يعني polyatomic ion? Like what? نسينا؟ انتوا على فكرة من مرة هذا chemistry 1 شاطبينه من مرة. Polyatomic ions يا يارا، شو هو؟ شو هذول الكربونات وفوسفات ونايتريت شو اسمهم هذول؟ polyatomic ion، ion بس في أكثر من اتوم. شو يعني polyatomic ion؟ ion يعني يا بلس يا ماينس، بس هو polyatomic. لما نقول Cl minus this is not polyatomic. ليه؟ لأنه Cl minus one atom one ion. بس لما نقول CO3 minus 2 that is a polyatomic ion. لما يكون في عندك ايش زي هيك نايتريت فوسفيت الى اخره، بدل ما تقعد تعد في الكربون atoms you can count it as a whole. That's what it says here. one polyatomic ion one polyatomic. راح تفهم شوي بس اصبر لبين ما نشوف. What time is it؟ ظهر عشان هيك الالارم for the second class. خلينا let's move to this one. I never balance an equation by changing the subscript in a chemical formula. ايش هم السبسكريبت؟ شو يعني subscript؟ The one that is where؟ down. طيب هذول اللي down ما بنلعب فيهم. يعني خلينا ارجعكم لورا بس for a moment. هاي الايكويجن when we balance it we multiply by coefficient. بس ما رحنا غيرنا قلنا اقول لك خلاص انت بدل ما هاي الشغله اعملها HCO2. طب هذا بصير different compound. That's hydrogen peroxide. ذول السبسكريبت you don't subscript I'm sorry. You don't play with them. This is not the one to be used for balancing a chemical equation. You balance it by changing the coefficient in front of that, but not the other ones. So that is the rule here. This one is make sure that all the coefficients are in the lowest whole number ratio. خلينا نرجع كمان مرة عشان نشوف شو معناها. Here we have 2H2 plus O2 plus to produce 2H2. لو عملتها 4H2O مع 2H2O مع 4H2O in this side, it's still balanced. But is this true? No. It has to be the lowest whole number coefficients. يعني إذا طلع عندك شيء that you can divide by, you have to divide it by يعني لازم يكون to the minimum. ما بتقدر تضرب تقول يلا خلينا نضربها في 5. You can, that is true. In terms of being balanced, yes, it is balanced. But is it correct? No. Why? Because it is not accurate in this case. طيب خلينا نخلص هذه المرة. قديش ضايره؟ في وقت إن نخلص من القصة كلها. طيب balancing this chemical equation very quickly. Let's take a look at this one. AgNO3 plus copper to produce carbon nitrate and silver. هذا اللي كنت referring to. هذا النيتريت NO3 ما هو موجود هنا. بدل ما تقعد تعده بالواحد يعني بالنيتروجين واكسجين you count it as a whole. That was the rule اللي كانت هون. اوكي؟ فاول شيء بنبدا بالسيلفر. سيلفر 1 1 that's fine. نيجي للنيتريت NO3 هنا في NO3 2. فمعناها we have to multiply this by 2. هاي اول واحده. بعدين الكبر is 1 copper that's fine. بعدين بنلاحظ نيجي نرجع للسيلفر كمان مره صارت 2 ف we have to multiply it by 2. اذا 2 in here and 2 in there will do the job. Right? This is the first 2 and this is the second 2. هيك بصير equation balance. Let's see this one. AlO2 Al2O3. اولا الالومنيوم needs to multiply by 2. نضربها في 2 خلصنا من الموضوع. طيب وهاي by 3. طب by 3 بصيروا 6. معناها we multiply this by 2. معناها نرجع للالومنيوم we multiply it by 4. Is that يعني you are following with me? اول شيء we multiply this by 2. This is the first thing based on what we have here. But as I said, once you balance one element that is combined with another element, you have to recheck the element again, even if it is balanced. في مشكلة؟ ماشي؟ Al2O3. طيب. Then we multiply this by 2 in order to balance the oxygen, and then we multiply this by 3 also to make sure that they're balanced, but we have to recheck this one because the aluminum now is 4, so that will become 4. هيك بتصير equation is balanced. 4 aluminum, 3 times 2 and 2, that is 6. Okay, is this the minimum? Yes. ما بتقدر تنزل هاي أكثر من 3 لأنها this is an odd number. طيب. كمان example, C3H8 with oxygen to produce carbon dioxide and water. That is carbon, we have 3 here and 1 there, so بنضرب هاي في 3. ال 8 hydrogen, this we need to multiply by 4. طيب نرجع هون، سيبك من الأكسجين هون. This is we multiply by 3, 3 times 2, that is 6. وهنا 4, that is 10, so we multiply this by 5. عشان هيك بتصير هاي 5 oxygen، هاي 3 carbon والآخر. طيب خلصنا. Okay, you see that it is very easy, but though it is very essential. إذا ما بتعرفش تعمل balancing the equation, later on في chapter 12 لما نصير نعمل calculations, you cannot do calculations on unbalanced equation. طيب احنا بنجيب لك في الامتحان equation that is not balanced. إذا ما عرفتش تعمل balancing, the whole calculation راح تطلع غلط. فذلك this is why it is يعني wasting, if we the right word, of one whole section in order to make sure that you understand it. بدك شيء ولا بس؟ ها؟ Can I take your attendance? ولو ما بديش. لا. Can you take my attendance? I will do that. Oh. طيب I will do that. المرة اللي فاتت حطيتكم كلكم حاضرين هيك just for the يعني sake of شو اسمه. طيب خلينا stop this first. إذا ما عندكش مانع يا يارا.